For letter A, it says find the radius of convergence. So we're going to do the ratio test for that. So that involves going to this general term right there, replacing the n's with an n plus 1. You're going to divide it by the original, which means you'll multiply it by the reciprocal. And I did our normal simplifying things there, where I'm rewriting this as x to the n times x to the first. This is -3 to the n times -3 to the first. Those cancel out. The x to the n's cancel out. This has a negative exponent, so I moved it up to the top. And then we have the absolute value there, so that becomes positive. Pull out your non-n terms there with the absolute value. That limit answer is easy. That's just 3. And then you just move that 3 over, you get the absolute value of x is less than 1/3. Now that is your radius of convergence, and it kind of gives it away right there. It says the absolute value of x is less than r. So once you match that format, that's your radius of convergence right there. And if it asks for the interval of convergence, that's when you make your lesson sandwich. You get your interval, and then sometimes you gotta check those endpoints right there. So that's all we had to do for letter A. Now letter B there was another little phrase in there that was a little bit tricky. We kind of did this in the past, but they worded it differently here. But it says, write the first 4 non-zero terms of the Maclaurin series for the f prime, the derivative of f, and then express that as a rational function. Now, I've been telling you, anytime it gives us a string of things like that, and you see the derivative notation, what you're meant to do is take the derivative of those few things. If I saw an integral notation, I'm going to integrate those few things there. So that's what I'm going to do in this first part. I'm just going to, for the first 4 terms, I'm going to take the derivative. So the derivative of x is 1. The derivative of this, I'm going to multiply by the power d to the power 1. So the 2's will cancel. I'll get a -3x. And then here, this would be a 9x squared to get that. And then I needed a 4th one, and I didn't have a 4th term up here. So what I did, this was plugging in n equals 1, n equals 2, n equals 3. So I took 4, and I plugged that in for the n right there. So that gave me -3 to the 3rd over 4, x to the 4th. That gave me -27 over 4x to the 4th. And so that was a 4th term for f. And then to get the 4th term for the derivative, just do the derivative of that. Multiply by the power decrease power by 1, the 4's cancel, and you get that -27x cubed right there. So I kind of like that, all right? Even if the language looks weird, you see that derivative notation in there, take the derivative of those few terms right there. And I got the first 4 terms. And then what might have been unclear, it then said express that f prime as a rational function. Now, we've done this before, except it didn't use the phrase rational function. It says find to where the series converges to. So if you see the language where it says find the sum, or find the series to which it converges to, or if you see rational function just means get a fraction for it. So if you're supposed to take an infinite series and get a fraction for it, they're meaning for us to find the sum, which means it's probably going to be an easy thing that we could find the sum of, right? And so I think if we look at that, we all know that's a geometric series. We're multiplying by -3x each time, where a is the first term, r is what you're multiplying by each time, and then your sum formula for an infinite geometric series is just simply that a over 1 minus r. So I did 1 over 1 minus that -3x. That gave me 1 over 1 plus that 3x. So maybe you're kind of confused on what to do there, but yeah, at least we got that trick up our sleeve now. If we see anything with the sum, find a fraction for it, find a rational function for it, or find to where the series converges to, you're trying to get one single fraction for that thing, so we got to use that infinite geometric series. And then letter C, they have us do this a couple times here. These problems are always a little bit weird to me, but it says write the first 4 non-zero terms for the e to the x. That we're going to have down. And I think that was worth a couple points out of the 4 or 5 points that this letter C was worth there. I think there's worth 4 points possibly, and then this is worth a couple of them if you just get that down. I'm not sure though, but you get something. This is just from your purple sheet having that memorized. And that's probably like one of the easiest ones to memorize there. If you look at those long enough, there's patterns to them, like the sines and cosine. They can alternate signs. You got your odd numbers and stuff in there, but the EDX is just something so it squared over 2 factorial, some cubed over 3 factorial, and so on. So that's the first part of that. And then it says use that to write a 3rd degree. So all I need is a 3rd degree for this EDX times f of x. Now, if I would have saw e to the 4x, then I just replace those x's with 4x's, and that's kind of more normal to me. But I'm supposed to take this e to the x and times it by f of x. This is that Taylor polynomial representing that f of x right there. Okay, so we're supposed to multiply these terms times it by that term. And I know that's weird because those keep on going on forever and ever and ever, but we're just going to do so many terms, and then we're going to cut it off once we have our 3rd degree. So I might go a little bit extra, and then we'll cut terms off at the end of this thing, right? So I just wrote down the first so many terms of that. I figured I didn't need to keep on going there because that's going to have an x to the fourth in there, and I don't care about that. And then I just wrote down the first few terms of that f of x right there from the original function. So there's my e to the x times f of x, and I'm just going to straight multiply. I'm going to distribute, okay? So I took the 1 distributed, took the x distributed, took this distributed, and then I think once I got to here, I stopped because when I realized when I was distributing this one, I was getting higher degrees than that 3 right there, okay? And I already had a couple higher degrees in there, so I think I got everything that I need here, and now I just was super cautious. I was like underlining my x to the first 1 time. There's only one. I underlined the x to the squares 2 times, like going back to like, you know, algebra days and stuff, right? And then underline my x cubed 3 times and just combining like terms there. So all I'm doing is combining like terms, adding up the fractions without the calculator. So that was a little bit weird, but it's good for us to get exposure for that, because that's this thing is like we're just getting all these tricks up our sleeves, and we got all these things that we could be trying, and hopefully that stuff gets better and better. But at least we know, like, once you see this, like, okay, I can do that, and I have something else that I can try right there. Dogs.